Okay, so here we go. We're going to talk about hypothesis testing for a mean. And there are a couple different ways that we can do this. There are 3 different types of hypothesis testing for a mean, similar to the kind that we did with confidence intervals. There's a hypothesis test for a mean where we don't know the standard deviation, and that's going to be called a t-test. There's a hypothesis test for a mean where we do know the standard deviation. That will be called a z-test. And then there's a hypothesis test for data. So we're going to start out with one where we don't know the standard deviation, the population standard deviation. So we already know how to write the claim, the null, and the alternative. So we're going to start with that. The USDA claims that hot dogs have a mean sodium content higher than 325 milligrams. Okay, so we're going to write that down. The mean is higher than 325 milligrams, and we know if that does not have a equal sign, that will be your alternative, greater than 325, and the opposite of that would be less than or equal to 325 milligrams, and this time we are doing a t-test. It says test at the 0.01 level, alpha equals 0.01. That's the percent of time that you can stand to be wrong. Later we would talk about a type 1 and type 2 error, but we really don't have time to do that in this class, so we are just going to move on and do the actual test itself. We're going to write down everything we know. We know the sample size is 40. We know the sample mean. The sample mean is 327. The sample standard deviation is 3.2. And the sample mean that we're testing against is 325, and that will be called mu naught, 325. So write all of that down, and then we're going to pull up our calculator. So maybe pause for a moment, and then we're going to pull up the calculator that is hypothesis test for a mean with statistics. Sigma unknown, because we do not know the population standard deviation. Instead, what we know is the sample standard deviation of 3.2. We know the sample mean, 327 milligrams. We know the sample size of 40. We know the population mean that we are testing against, 325. Okay, this is really important. This has to match your alternative, and you'll notice that none of these have an equal sign. So come over and look at your alternative. Your alternative is greater than, so this needs to be greater than. It will always match your alternative. Okay, and we're able to do this test for the same reason that we could do the confidence interval test, because we have more than 30 in the sample. If we didn't have more than 30, whatever you're testing would need to be normal. So calculate, and you will come down here and you will find this value. P is 0.000001. Okay, so we're going to write that down. P is 0.00001 something. Okay, I can't remember what that was. 1 something. Okay, but whatever it was, you're comparing P to alpha. P is less than alpha. And if you look on your sheet that says, do not lose this sheet, it will say P is low and the null must go. P is low, null must go. So, very, very lightly, take your pen or your pencil or whatever, and you're going to come up here and you're going to mark out your null. P is low, the null must go. Mark out your null, and you're going to circle your alternative. Okay, you're going to either mark out one or the other. Mark out your null or mark out your alternative. P is low, the null must go. Okay, and then you're going to check to see, does whatever you have match your original claim? And it does. And that makes you happy. And because it makes you happy, you can say that there is enough evidence to support the claim that the mean content is higher than 325 milligrams, and I'm not going to write all of that down. Okay, but I hope that makes good sense. And we're going to do one more of these. You're going to pause this and you're going to write this down. Okay, so let's look at another one. Seismologist from UNC Chapel Hill collects data on 600 earthquakes. That is N. She found the following summary statistics. X bar, sample mean, is 5.92. S is 4.93. Use the 0.01 significance level to test the claim that these earthquakes are from a population mean equal to 5.75 kilometers. So, 5.75 kilometers. It's either equal to 5.75 or it's not equal to 5.75. So equal to would be your claim, equal is your null, not equal would be your alternative. Okay, we're doing a t-test again because we have S. Okay, alpha is 0.01, t-test, sigma is unknown. And I went ahead and took the liberty of filling all of this out. You can stop the video if you need to for a moment. Standard deviation, X bar, N, the population that we're testing against, and this time X is not equal. Okay, this time P is equal to 0.728. So P is larger this time. Okay, so P is large. Okay, so P is larger than alpha. P is greater than alpha. So 0.728 is larger than 0.01. So P is high, null will fly. Okay, the real way you say that is you fail to reject the null hypothesis. But we're going to say null will fly. Circle your null, mark out your alternative, and check to see if they match. And they do match. So again, we can say there is enough evidence to support the claim that these earthquakes come from a population with a mean equal to 5.75 kilometers. And you'll notice that it did not matter if the claim was the null or if the claim was the alternative. You can still get enough evidence to support your claim whether P is high or whether P is low. It did not matter. What matters is if what you have left matches your claim. Okay, one other quick little thing. If you were to happen to get a problem where you know sigma, you would be doing a z-test. Where you have sigma known, it would say something like the standard deviation of all offenses is known to be something 12 months. In all my years of doing statistics, I have rarely had anyone that I've ever worked for where I've actually known the standard deviation, maybe one time ever. So you will probably never in your entire life actually know the population standard deviation. Maybe if you work for, the Center for Disease Control, maybe, but probably not. Okay, and if you have data, look at this last problem. So if we have data, you don't have to go through and find your standard deviation first and your mean first. You can just go through and enter your data. So this is the calculator that you would use there. Hypothesis test for a mean with data. And you would just go through and enter your numbers, although you would have to go through and put commas in between each one of these, and then find your mean and standard deviation and do your test. So it would be just like the other test that we've been doing. Okay, so I hope that helps. P is high, null will fly. P is low, null must go. Hypothesis testing is cool. I hope you really, really love it. This is something that you may use going forward, particularly if you are going to grad school. So I think this is awesome. Hope you love it.